Hello everyone, welcome to our channel. Today we will be starting with our first LeetCode problem, which is to sum. So let's get started with the problem. Let's go to the problem first so that we understand the problem before getting to the solution. Here what the problem states is we are given an integer array and an integer target, and we have to return indices of two numbers such that they add up to the target. Okay, so you may assume each input has exactly one solution. So this is our assumption, and you may not use the same element twice, and this is some rule that he has specified wherein we can't use the same element twice. And the problem has given us a flexibility that we can return answer in any order, which is fine. So before going to the solution, let's understand the problem. So what the problem states is, on a high level, we are given an integer array. Let's assume we have 1, 3, 2 and 4. This is our integer array. And we are given a target, which is, let's say, 6. So now we have to find two numbers and return their indices. This is very important. We have to return their indices such that they add up to the target. If you see, we just have one combination which will give us a target of 6, which is 2 and 4 will give us a target 6. So this combination will match our answer, and we know that array starts from 0. So our first index is 2 and our second index is 3. This has to be sent in the answer. Hope you understand the question. And it is explicitly specified that each input has exactly one solution, and you may not use the same element twice. Example, like if you have 3, if you have the same array, you can't use this 3 twice. You can't make that your output is, your first index is 1 and your second index is 1 again. You can't. This is not allowed. So let's get started with our brute force approach. Here, if you see, since I need two elements that boil down to the given target, which is 6, I can just loop through the array twice and get my answers. So if you see, first pointer, second pointer, sum. So let's assume that these are my indexes. My first pointer starts from here and my second pointer starts from here. So first pointer is at 0, which has a value of 1. Second pointer is at index 3, so is at index 1, which has a value of 3. 1 plus 3 is 4, which is not matching our target. Now we can increment the second pointer and move it here. Now the first pointer is at same 0 location, which has a value of 1, second pointer is at second index, which has a value of 2. 1 plus 2 is 3, which is not matching our target. Now we can move our second pointer further, which is now our first pointer is still at 0th location, which is 1, which has a value of 1. Second pointer is at 4th location, so third location, which has a value of 4. 1 plus 4 is 5. 5 is not equal to 6, which is our target. So this combination is wrong. Now second pointer has reached the end of array. It can't go beyond this. So instead of incrementing the second pointer, what we do is we increment the first pointer. Now first pointer is at location 1, which has a value of 3. And what we do is we always put the second pointer after the first pointer. The initial position of second pointer, which is should be first pointer plus 1. So our second pointer is at location 2, whose value is 2. 3 plus 2 is 5, which is not matching our target. So we carry on. What we do is we increment the second pointer. Now our first pointer is still at location 1, which has a value of 3 here, and our second pointer is at location 3, which has a value of 4. 4 plus 3 is 7, which is still not making up to our target. So this combination is also discarded. And now second pointer has reached end of array. It can't move further. So we change we move the first pointer from first position to second position, and we put the second pointer just after first pointer. So it is at third position. Now the first pointer is at second position, whose value is 2, and the second pointer is at third position, whose value is 4. 2 plus 4 adds up to 6, which is matching with our target. So we found a solution where the values are 2 plus 4, but here remember, most important point is in the solution they asked for indices, not values. Indices are nothing but the array locations whose value make up to the target. So here although 2 plus 4 is making up to the target 6, we are not interested in 2 and 4. Rather, we are interested in their indexes, which is 2 and 3, which is this 2 and 3. So our indexes are, the first index is 2 and our second index is 3. Our solution set is 2, 3. Hope you understand the solution. Now let's come up with a framework for writing code. Before implementing the solution. This is a generic framework anyone can use. So generally we are asked to write a function to get our job done. So let's write a function. Let's start with a function called calculate to sum. So what this function gets as an input is an integer array. Let's suppose this is nums, and all of my coding will be in Java. Okay, so this is the function, and what the function has to return is it has to return the indices of two numbers. So indices are returned in the form of an array. So our return type is integer array. Now whenever the framework for writing code is, initially you have to handle all our base cases. Base cases are nothing but conditions which can break your code. Should be handled in base cases. Then comes your actual logic. Then comes your solution. This is something that we have to always follow. Okay. So what you can do is, since he has asked in the question that you have to give return indices of two numbers. That is, if the num's length is less than 2, we can never find two indices. Like if you have an array with just one element, 0 or 10, can you find two indices such that it meets the target? No, right? So our first base condition would be, if num's length is less than 2, we directly return, for now let's keep an empty array. Okay, now comes the actual logic part. So in our logic, if you see, it's a basic double for loop, wherein our first pointer is initialized with 0 first, and then 1, 2 and 3, whereas our second pointer always follows the first pointer. So it's like this. We can take two loops where I starts from 0, I is less than and we have another loop which is for the second pointer, or maybe you can, yeah, our I is our first pointer and j is our second pointer. J is always I plus 1. Like while implementing, we saw that second pointer should always be after first pointer, because if you keep second pointer also in the beginning, then you are unnecessarily recomputing the results. Like and you have to ensure here that I should not be less than nums.length. I should be less than nums.length minus 1, because after the first element you have to always find the second element. Like if you have 10 and 12, your I can just reach here, your first pointer can just be this. If your first pointer itself is reaching the last element, then where is the scope to find the second pointer? You'll never find the second one, right? So for that reason, we have to stop the first pointer in n-1 index, not nth index. Okay. Now in this loop, what's our condition to find the solution? Our condition to find the solution is, when we find two numbers and the sum is equal to target, we have to return those indices, right? So we assume that target is sent as a part of input. Okay. Now we have to sum up values at these two indices, which is if this is equal to target, this should be our condition. If this condition meets, then you can return a new integer array with these values. Here your integer array should not contain the values itself, it should contain the indices. So that's why instead of nums I nums j, we will be returning I and j. So this is the solution for this for loop. I am closing here, and this for loop is closed here. in case you never find, like our question told that we will always find a solution, hence this is fine. But as a final condition, we should also have like, in case we don't find a solution, an empty array with two size will be returned. So this is the brute force solution for this. Hope. Okay, let's start our video by computing the time complexity of our brute force solution. So in the brute force, what you are doing is you are running the loop from, this is our first loop and this is our second loop. You are running your first loop from 0 to n-1 index, and you are running your second loop from i+1 to nth index. So what if you see it, if 1 3 2 4 is your array, what you are doing is in the first loop you are fixing this guy, and in the second loop, in the first attempt, you take this guy. This is the first attempt. In the second attempt, what you do is you discard these guys and you take this guy. In the third attempt, what you do is you discard these guys and select this guy. That is, here the sum is 1 from here and 3 from here, which is 4, which is not meeting our target. In this step, 1 is from here and 2 is from here, which is 3, which is not meeting our target. Same way, in the next step, 1 is from the top and 4 is from here, which is 5, which is not meeting our target. So this is our step 1. Now, since with 1 and all other cases you didn't get any combination, you stop incrementing the second pointer and you increment the first pointer from 0th location to first location. So the first loop is in this state now. Your 3 is fixed now, and in the second loop, in the first attempt, you fix this guy 2. So your 2 is from here and your 3 is from here. 3 plus 2, which is 5, which is not meeting your target. Now in the second step, you disregard all this and you select 4 and 3 from here, which is 7, which is also not meeting a target. So what you do is, even with first fixed here and second reaching the end, you didn't find any solution. So you second cannot be incremented. The only option you have is to move the first one from first location to second location. So the state of first loop changes like this. Now your second is fixed and you just have, now your first is fixed to this location and your second has only this option, which is 4. All these are not possible. So your 2 comes from here, your 4 comes from here, which is 6, which is matching our target. Hence, for first we selected the index to be 2, and for second we selected the index to be 3. This was our answer, 2, 3. If you see, the first loop is running from 0 to n-1, and the second loop in the worst case will run from 1 to n. So here logically this is n and this is n. So your time complexity will be big O of n into n, which is nothing but big O of n square. Now how can we improve our complexity? If you go back to our analysis here, what do you see? You started with 1 and you moved your pointer from 3 you fixed your 1 in these 3 cases. your second pointer traversed to 3, 2 and 4. And all these cases didn't yield you a target, proper matching target. So what did you do? You moved your first pointer from 0 to first location. This is the first location, these two cases. And you are again rotating the second pointer to second and third positions. Second and third positions. You already knew that the second and third position had 2 and 4 values in it. Why didn't you remember here? So this is the optimization that we can do. As humans, once you see something, like example, you are going to your home from your school and you saw a pani puri shop on the first day, and on the second day again you are walking through the same path. Will you not remember that same pani puri shop again? You do, right? You have memory and you do. And you do remember that pani puri shop is at that point. In the same way, computers also have memory. We can use that memory to store previous occurrences. And try. So what we can do is we can memorize our previous occurrences. Let's take an example of same array. For memory, I'll be using a key value pair memory so that my lookup time is drastically reduced to O of 1. Okay. Now what I'll do is I'll start my pointer from here. Okay, before getting into the pointer, let's start with the equation. If I have some a plus b equal to some target and I know my a value, how can I get my b value? B value will just be target minus a. Agreed? So what I'm trying to optimize is, if I have my a as my current pointer, let a be my current pointer, current value, and for b, what I'll do is I'll not go through the array again, which is costing me a lot of iterations. What I'll do is I will check for target minus b. Since b is target minus a, I will check for target minus a in my key value store. If I find that, then definitely I can find my indices. If it's not present in my key value pair, then I can just increment my pointer. So initially I'll start with 1. Here my a is pointing to this, which is 1. My target is 6. So target minus a is 5. Okay, do I have my 5 in my memory? No, because I never saw 5 till now. I just saw 1, which is at index 0. I've added to that memory. So this is not a valid scenario. What I'll do is I'll increment my a. Now my a is pointing here in the first index. What's the value in first index? 3. What is my target minus a? Target minus a is nothing but 6 minus 3, which is 3. Do I have 3 in my memory? No, I don't. So now I will be adding 3 into my memory. 3 is the memory, 3 is my value, and where did I find it? I found it at location 1. So location will be my value. Now I will increment my a to second location. What's my value at second location? It's 2. What will be my target minus a? 6 minus 2, which is 4. Do I have 4 in the memory? No, I don't. So my next step would be adding this current location to my memory, so that in case I need this in my next iterations, I can use it. So my value is 2 and it's found at location 2. Now my A will be incremented to the last location, which is 3 and which has a value of 4. Now my target minus A is 6 minus 4, which is 2. Now I'll check whether 2 is available in my memory. I'll just check the keys. Okay, I found 2 and it's at location 2. Okay, I found 2. So that implies that somewhere in my previous states I saw 2. That means I have two numbers, A plus B, which is making 2 the target. Right? What is A? A should be our current location, which is 3. What should be B? B should be the location where I found 2 previously, which is nothing but the value of this memory, which is 2. So 3, 2 is my answer. By doing this, what we are doing is we are traversing the array only once, right? So our time complexity is just O of n, but our space complexity increases here, which is nothing but this is also O of n, because we are storing whatever we find into memory. So in case if you find memory, if you don't find any solution, all of your n elements will be added to your memory. So in the worst case, your space complexity is also O of n. So let's start with the code. Let's implement the same function, calc to sum. Here we get an integer array and you get an integer target. And what you need to do is you have to return an integer array having indices. Same thing, we have first our base cases. So if your nums array length gets less than 2, then return a new empty array, which is mentioned in our case, in our question, that you will always find a solution. So this case doesn't make sense, but it's always good to have base cases. Now comes your actual logic. What are you doing? You're just going through the array from I equal to 0 to I equal to I is less than nums dot length minus 1 length, and you're just incrementing. While doing that, you're checking if your memory. So let's initialize our memory first. So for memory, you can take a hash map, which is integer comma integer. Okay, so first you will check map dot contains key. Similarly, what we did, we are fixing one location, which is A. Here in case it is I, and we are searching for target minus nums of I. Nums of I is nothing but value at ith location. I is our pointer, nums of I is our value at that point array location. So if it contains a key, then we got our answer. Return new int. The first location is I and the second location is the location where you got target minus nums of I. Else what you do is you always add your existing value to your memory, like we were doing here. If I don't, like here, I was searching with A is 1 and I had to find 5. At that point, this is the first step. We didn't have anything memorized. Like it's like first day going to school where you have your entire memory empty. And on the first day, you're trying to search for something. You didn't find anything. Later, you went to your school first on the first day and you remembered that your school is in some X location. So you memorized it. Like I found my school at some location. 1 is your school, 0 is the location. You start memorizing things when you didn't find it. So here also, if this if case is missed, then that implies you didn't find a solution. So in that case, what you do is you just put your value, which is nums of I, and you say that it was at ith location, so that in the next iteration, when you're in the for loop, you can check that memory. Our memory is nothing but map here. Here you are inserting, you're memorizing things. At this point, you're memorizing things. At this point, you are checking your memory. Okay, now you have to have a default base case in case you don't find an answer. In case you don't find any answer, you just return new integer empty array of size 2. So this is our code. I have already mentioned space and time complexity for our optimized solution here. So that's it for this video. Hope you like it, and we will be posting more LeetCode problems on the same channel. Please subscribe, like and comment if you like it. Thank you. Bye.